There's so many things that I love about Northwestern. I think what's so fun is that it's a well-rounded education. So when it comes to the small class sizes, I feel like I have a one-on-one connection with professors, and that's super valuable.
This university has given me a lot of different opportunities, actually.
I really prefer just designing my own stuff and making it better over time and making it closer to the picture I had in my head. And that element of designing and upgrading is something I really like about being an engineer.
I am Mike Jacobson, and I'm Professor of Engineering here at the University of Northwestern. We offer a Bachelor of Science of Engineering, so it's all engineering. And then within the program of engineering, there's 3 concentrations they can do: electrical engineering, civil engineering, or mechanical engineering. All of our junior level students actually have a lot of lab experience and lab-on learning. So control systems can be taught purely theoretical, but we want them to actually have some experience with hands-on learning. So the theory they learn, they're applying to this LJ trainer. They're trying to control the speed with various loads.
I'm a really hands-on guy, and I learn by doing things myself, like tinkering with things. And this lab, the other labs I've taken, have all really helped me to kind of visualize and understand the theoretical part of our studies a lot more.
I really like the hands-on more because you get to see the actual concepts that you're learning come together. Like physically seeing it go and how much just like a little change can drastically change something is something really cool that like you don't quite get to see as well on paper.
We call this our simulation lab. In this lab, actually, we teach a lot of courses. We have SolidWorks, but probably the biggest one that I use here is MATLAB from MathWorks. And that is for teaching of control systems. We teach circuits in here. We teach SolidWorks and fundamentals of engineering in here.
I'm Siu Tan, and I'm Associate Professor of Engineering here. This lab is called Thermal Fluids Lab. In one semester, we have them do 12 different experiments. They had to take a fluids class and then a heat and mass transfer class. So it's essentially the lab for both classes.
There's a lot of really fun machines in this lab, a lot of variety of them for sure. I liked the one with all the different water pipes, and you can see all the different ones just because it's so big and you can see so many different measurements all at once. And that's just something cool that you don't really get to do anywhere else.
We are actually surrounded by so many equipment here. They are designed pretty well because they are compact, so the footprint is not very big. So we can obviously fit a lot of different type of equipment here. I think it's kind of rare, but I'm also really happy that the school decided to purchase all this equipment and have such big variety for the students.
A lot of our work involves design. Assembly and testing are 2 other big parts of what being an engineer is. Testing is essentially what you do in a lab. And when you're an actual engineer in the field, you need to test the products you're designing to make sure they actually work. So testing like you do in a lab environment like this really helps you nail how to collect data and figure out if something works or not.
When you have the lab reports and you have all of your collecting the data, and then you see suddenly, oh, we just did this lab, and now you're understanding parallel to the class, the content, and you're like, wow, this is what this actually means, and it's a cool thing.
I think definitely the mechanics lab, when we actually got to run something through a fatigue cycle and actually watch where the fatigue forms and why it breaks the way it does. That makes a lot of sense because you're doing the math, you're multiplying it out, and you go from symbols to numbers and you never actually see anything. But when you come in here and break stuff, then it makes sense.
Of course, theory has to be applied when you're actually in the workforce. So by having this experience, they realize that their calculations don't always line up exactly right. There often has to be little adjustments or changes. And so I think just because we're applying this, but the theory, like I said before, it could be pressurizing a tank or controlling the flow of fluid, or it could be heating of a room or controlling the airflow. All these control systems, they essentially have the same theory behind them.
Sometimes it can be so abstract, and then you get into industry and you haven't seen what actually these things do. And so I think that's super valuable to have actually already applied the knowledge, as opposed to going into industry where you're supposed to apply the knowledge just to then be like, well, I've only done abstract stuff. So it's more useful when you've actually been able to apply it already.
We are unique in that we are a private, faith-based university.
I do see that God is working in the school in many ways, And I do see some students, they come here and then their faith just grow.
And our view is that engineering doesn't have all the solutions to the world's problems. Engineering is good for problem solving, but we actually want a more rounded student that we're graduating. And I think that's what industry is seeing, that if you just have engineering, that's good. But if you have engineering and ethics, that's actually even better.
Coming from a smaller school is definitely a plus because some of the students say they have so many different opportunities to interact with professors, to interact with classmates. They know how to interact with people. It's kind of crazy. A lot of them, they can get internship when they're sophomore year, and that was kind of unheard of before, and now it's not that rare.
And I get calls for internships. They will say, I want to hire a soon-to-graduate senior. And I said, no, you're dreaming. They've all been hired already. They're not looking for internships. They already have jobs.
The outlook is really, really positive for engineering graduates. Not only that you will be able to find a job, you will be able to find a well-paid job as well. Several students have mentioned that the problem-solving part and creativity part, that is so fundamental to being a human, that you will be able to solve problems to help others, to create something like beautiful in your head that you can actually feel it to fruition, and maybe you can enjoy it yourself or maybe other people can enjoy it.